Hey there. Just wanted to do some examples with you to help you solve by factoring. If I sent you, it's probably because you're struggling a little bit. Um, just right off the bat, like things we want to think about, like we're supposed to be solving. So, what does that mean to you? When I think about that, one of the things I think about is what's my goal? And so if I'm solving, my goal is to end up with x equals as part of my answer, or as my answer. Um, and Another thing to think about, that when we are solving quadratics, um, we're really trying to find the easiest way to think about it is that we're trying to find the place where that graph crosses the x-axis. We're looking for those x-intercepts. And that place, that way we know that what x is equal to. When we find those, well, what we know about x-intercepts is that the y value is always 0. And so when we go to solve a quadratic, we want it to be, equal to 0. And so it's always the place to start. Like, does the equation equal 0? And so you see in this case it doesn't. So our first step is going to be to set one side to 0. So I'm going to move the 42 to the other side by subtracting it. So 0 equals x squared minus 11x minus 42. And so now that everything's on one side, I want to factor this. And the reason I need to factor it, I can't just like get x by itself straight away, is because there are two different types of x's. So we need to look at this down so there's just one type of x in the problem, then we'll be able to solve for that x. But because there's x squareds and x's, we can't separate them anyway, and or I can't just square root this because I don't know what the square root of 11x is. So be able to factor and get it down to its pieces. And again, there's the next kind of thing is like, what does factoring mean to you? And so to me, factoring is like finding things that multiply together to be something else. I want to, if I say what's the factor 30, I want to say, well, 5 times 6 is 30, or something like that. So it's kind of the same thing. Like we have this statement of x squared minus 11x minus 42. What times something else equaled this, right? These two binomials, something. We want to find those things that equal this. When we multiply together, we're trying to break it down into its, where it came from. And so, the first thing we should always ask ourselves when we're factoring is, is there anything in common? So just looking here, I'm ignoring the 0. Is there anything in common here I can take out? And so for these, there's nothing in common, so I can't use the GCF. And now that there's, after that, it's if there's 3 terms, then it's, using our AC method. So looking at our A value of 1 and our C value of negative 42, so our AC is, 1 times negative 42 is negative 42. We need the AC value to add to that B value. So I need to find factors of negative 42 that add to be 11. So what are factors of 42? 1 and 42, 2 and 21, 3 and 14, 4 does not go into 42, 5 does not go into 42, 6 goes into 42 7 times. So there's all the factors of 42. And I know I'm done because 6, 7, there's the 7 already. So if I'm going to get negative 42, one of these numbers has to be negative. And I want a negative sum, so that means the bigger number has to be negative. So 1 minus 42, negative 11, nope. 2 minus 21, 11, negative 11, nope. 3 minus 14, oh yeah, there's negative 11. 6 minus 7 is not negative 11. So what do I do with that 3 and that 14? So they go back in the equation. The x squared doesn't change. The negative 42 doesn't change. But now it's 3x, positive 3x, so plus 3x, and minus 14x. So those go back into the problem. What we've done is split that middle number, that b value, up. So it's still equal to negative 11x. Okay, and we had to do it a special way. That's how we also get the 42. Okay. Now that we've got it, that number broken, we split the problem in half, and we go ask ourselves, the very first question we ask ourselves was there something in common, right? We're factoring, looking for common things. Both of these have an x in them, so I'm going to take that x out. And 0 is just floating along here. Don't lose that. Well, x times what is x squared? X times x. And x times what is 3x? So x times 3 is 3x. Oops. Go back and say the same question. What do these two have in common? So 42 has a 14 in it, right? So these both have 14 in it. And I do want to take that first sign. Since it's negative, I want to take out a negative 14. So negative 14 times what is 14x? It would be x. And negative 14 times what is negative 42? It would be positive 3. Again, right here is where you should be asking, like, are things going well? And the problem should talk back to you and say, hey, these are the same. They're exactly the same. That means things are going well. It means we just have one more step to finish our factoring. Those x plus 3's come together. And our x and our minus 14 come together. Oops. And so now we're done factoring. So we've factored, we haven't solved yet. So there's that one last step to solving this. It's each of these is going to give you an answer, right? There's going to be two x-intercepts. So you're looking at that first one saying, what value of x would make that 0? You're looking at that second one saying, what value of x would make that 0? And so one way to do that is to say, well, x plus 3 equals 0, and then you solve it, so x equals negative 3. And then you look at the other one and say, x plus minus 14 is 0, and so you add the 14 over, you get x is equal to positive 14. Most of the time we can do those in our head, just seeing that the sign's going to change. But it is good to remember like what you're doing when the problems aren't just where you can look at them. You just set it equal to 0, solve it, and that's your answer. So there's our two x-intercepts. There's our two solutions for that problem. Let's look at another one. A little trickier this time. So same thing here, right? So first thing we want to do when we're solving by factoring is check to make sure it's equal to 0. It is, so we're good to go there. Then I want to look at say, well, I'm going to solve this by factoring. I want to say, is there something in common? And there is not between all those, so I can't do that. So I just go to my AC method. So my A is 3, my C is negative 12, so my AC is negative 36, and my B value is 5. So I need two factors of negative 36 to add to be 5. Where does 36 come from? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 times nothing, and then 6 times 6. Again, I see that 2 6's there. Again, lets me know that this is also done. So I need negative 36. So one of our numbers is negative, but it's a positive sum. That means a smaller number has to be the negative in this case. And where I get 5 from? Here and here. 4, negative 4, positive 9 is 5. So those two numbers are going to go into the middle of the problem. So negative 4x plus 9x minus 12. So again, negative 4 plus 9 is 5. So that didn't change, that didn't change. This just looks different, but same value. Cut in half. And you look at those first two and say, what do they have in common? 3x squared and 4x. They both have an x in them. Well, x times what is 3x squared? X times 3x is 3x squared. X times what is negative 4x? X times negative 4 is negative 4x. And the next two, what do they have in common? 9 and 12 both have 3 in them. And it's a positive 3, so make sure I take out a plus 3. 3 times what is 9x would be 3 times 3x. 3 times what is negative 12? 3 times negative 4 is 12. Don't forget my 0. And am I doing all right? These are the same, so yes, I'm doing good. So the 3x minus 4's come together. And the x and the 3 come together. And so that last step, what value of x makes this 0? What value of x makes this 0? So you notice that the yellow one here is going to be the easier one, that x plus 3 equals 0, or you can just do that in your head and see, it's x equals negative 3. Well, that green one's a little hard to do in your head, so this is where, like, not forgetting what the idea is, that, okay, I need to set that equal to 0 and solve it. I can't just look at this and say, oh, x is blah, like, it can't be 4. 3 times 4 minus 4 isn't 0. So I'm going to add the 4 over, so I get 3x equals 4, and then divide by 3, so x equals 4/3. So I get this fraction, so no wonder I couldn't just see it in my head, because it's a fraction. So, but there's my two solutions, there's my two x-intercepts. Okay. So I have two examples there. I want you to try these two problems and bring those into me and show me what you got. Thank you.